In this video, we're going to talk about conditional probability. Let's look at this example on page 142. Complementary alternative medicine, including acupuncture, yoga, and massage. We have information concerning use of CAM in the past year and weight class based on body mass index. So let's look at the table here. So in the table it shows that 1% of the people who are underweight and used CAM, and 13% who are healthy weight and used CAM, and so on. And this 0.02 means 2% are underweight and did not use CAM, and so on. So you can see each number in one of those 8 numbers is the proportion of two things. So that's like intersection we talk about. So not only underweight, this person, not 1% of people who not only underweight, but also use the CAM. So it's underweight and CAM. So this is healthy weight and CAM, but this is a healthy weight and no CAM. So if we add the first row numbers, we get a 0.32. That means that's the percentage of people. 32% of people who used CAM, adding all these different categories. So it doesn't matter what this person, which category this person belongs to. Okay, so if we use A to denote the event that a person used the CAM, that would be 0.32 because this person could be in any of those categories. So we're adding all these different categories of people who use the CAM. We got 0.32. So that's P of the probability of A. And the probability B. If we use B here means an event that a person is overweight. So what's the percentage of people who are overweight? We look at the overweight. 0.12 plus 0.21, we get 0.33. So the probability of B. So 12% of people who are overweight and use the CAM, and 21% of people who are overweight and did not use CAM. So adding them together, use the CAM, did not use CAM, but they're all overweight. So we got 33% of people. So now let's look at the questions we have. The first question is, what is the probability that a person selected at random from this population we have used CAM? And we look at B also. A person selected at random is found to be overweight. What's the probability of the person used CAM? So these two questions we asking the same question in A and B, but in part B there's an extra condition, that one extra information, that this person is already known to be overweight. But in part A, this person, we don't know. It could be overweight, it could be healthy weight, it could be obese, it could be underweight. So that's the difference between these two questions. So part A, we know the answer is 0.32 because this person could be in any of these categories, and so we're adding them up. A person who used the CAM is 0.32, 32%. But the second question, since we already know this person selected is overweight, so we gotta look at this category. And what's the percentage of the people who use the CAM? And so out of these 33% of people, 12% used CAM. So we got to use 12% divided by 33%. So if you think this way, suppose we have 100 people, 33 people are overweight. 12 of them, out of these 33 people, 12 of them use the CAM and 21 people did not use CAM. So if we try to answer the question part B, that out of all these overweight people, what's the percentage of the people who use the CAM? So 12 people divided by 33. So the second question, we are having extra condition that we know this person is overweight. So 12 out of 33. So that's how we get the answer. 12 divided by 33, or you can say 12% divided by 33%, or 0.12 divided by 0.33. The answer is 0.364. So how do we get this answer? What's 0.12? 0.12 means, if we look at the table, 0.12 means overweight and use the CAM. We use the CAM and overweight. So use the CAM, we use the letter A. Overweight, we use letter B. So that means A and B. A and B, we use the notation AB, PAB, we talked about before. So this 0.12 means PAB, the intersection. And what is 0.33? 0.3 is probability of B. So how do we get the probability of a select person who's, we already know that the select person is overweight, and the probability of this person who used the CAM, that's 12 out of 33. Okay, so or use the formula PAB divided by PB. So that's how we get this formula, PAB divided by PB here. And for this probability, because there's extra condition B. B means this person is overweight, and the probability of this person used CAM. And A has no extra condition. It's just what's the probability of this person who used the CAM. And this one has extra condition. We put it behind this line, vertical line. So this is called PA. B is called PA given B is called a conditional probability. So if we look at the definition, conditional probability is PA given B equals PAB over PB. Or we can multiply PB both sides. So we get PAB on the top equals PB the bottom times PA given B. And from this example, we can see that PA without a condition B and PAB with the condition B, they're different. They have different answers. But sometimes you may get the same answer. If you happen to get the same answer, and we call A and B are independent. Suppose PA given B equals PA, we say they're independent. But if they're different, we say they're dependent. So like in our example, we found out these two numbers are different. So a probability without condition and a probability with extra condition, if they are different, they're dependent. If they are equal, we say they're independent. So it's easy to understand why we call that they're independent, because that means the condition B, this event B, will not affect the probability of A. So that means they're independent. In real life, we have examples. For example, if you throw a coin, if you toss a coin, the first time, the probability of getting ahead the first time is 1/2. And the second time, the probability of getting ahead is still 1/2. It's not going to be affected by what you get the first time. So, these two tosses, they are independent. So the probability of getting a toss the second time is independent of the probability of getting ahead at the first time. So there, in that case, PA and then PAB, they're the same. So that's independent. But in this case, they are dependent. So this different format is called multiplication law of probability. And independent, if we know these two events are independent, PAB is also equal to PA times PB. If we go back to look at the multiplication law of probability, because PA given B is the same as PA, so you can drop this condition, then you get a PAB equals PB times PA. So for example, if you look at the tossing coin, if you say PA means the probability of getting a head at the first time, at the first toss, and PB means the probability of getting a head at the second toss. So PAB means you get a toss at the first time, you get ahead at the first toss, and B, and you also get ahead at the second toss. So the probability will be equal to the probability of getting ahead at the second toss, which is 1/2, times the probability of the getting a head at the first time, which is also 1/2. So 1/2 times 1/2 is 1/4. So you can, if the two events are independent, we can do it this way. If they're not independent, then we cannot say PAB equals PA times PB. Actually, PAB equals PB times PA given B. So that's conditional probability.